Welcome back, friends of the Chicken Protocol. We are live from Financial Peace Plaza. Oh wait, that's Dave Ramsey. This is Professor H with the latest installment of the Packet of the Week. We have been talking about a particular address for the last couple of episodes, and this address is 192.168.1.1, and we were wondering what we could learn about this address. A couple of episodes ago, Nettingill there correctly identified these as private addresses as outlined in RFC 1918. And of course, these are used in conjunction with the IP network address translator, or the device that is specified in 1631. We just normally say NAT these days. All right, and we talked a little bit about how network address translation was primarily designed to handle address depletion and the size of routing tables. It wasn't really a security tool, and that we're probably not going to see very much of it with IP version 6 coming on, although that's not going to happen immediately. Certainly we see some efforts in the government and companies to move to IP version 6, but NAT is going to probably be around for a little while yet. Okay, I also wanted to know a little bit more about the network itself. And so this particular address, 1.1, is actually sitting on the 1.0 network. And the range of addresses, as indicated by that mask there, would be 1.0 to 1.255. But there's actually a lot more to the story than that. The network address there, 1.0, we get this from the mask, and I'll cover that here in a second. The lowest possible usable address, that is the address that you could assign to a host, is 1.1. Now the highest address in this range is 1.255. Now the highest usable address would be 1.254. Now it turns out that 1.255 is actually a very special address. It's called the directed broadcast, or a broadcast message or a broadcast address used to hit that entire network or subnet. Now the limited broadcast, all 255s, that means you're broadcasting at this particular network, or the network that you're currently sitting on. In actual practice, these two addresses are used in similar fashion. Now routers, now that we know that the address ranges from 0 to 255, or 256 possible addresses, and the usable addresses are 1.1 to 1.254, what usually ends up happening is that we have to assign a router address in this usable address space, and that's either low in the range or high in the range. So the examples would be 1.1 or 1.254. For those of you playing the home game, you know that a lot of the Linksys gear picks up that lowest address. That means that hosts are probably going to be assigned in the range of 1.2 to 1.253. So how did I figure out that the network address for 192.168.1.1 with that mask was 1.0? And the answer is that you AND the mask with the address. Well, how does that work? Well, if you convert everything to binary, as I've done here, and then you convert the mask to binary, and then you perform a bitwise AND. That means you go bit by bit, and you AND the IP address with the bit, or the corresponding bit in the mask. You would get the answer that you see there on the last line. Now the significant part about this is that anything ANDed with a 0 gets you a 0. So the only time that you will get a 1 is if the address bit and the mask bit are both 1, as is the case in the very first part of the binary pattern. Well, once you've done the ANDing process, you convert back and you get 192.168.1.0. Now this is a really simple example, but this ANDing process and breaking it out into binary works for every single subnet mask or even supernetting or CIDR problem, as long as you're careful about your conversion to binary and working back and forth to base 10 numbers. You may have noticed that I highlighted the last octet in the address, and that is because the mask in that octet is all zeros. That means that it doesn't matter what the value is of that set of bits in the network address octet. So anything from 0 to 255 when ANDed with this mask will result in zeros in the last portion of the address. And so no matter what address you use in this network, when you AND it with a mask, you're always going to wind up with the same network. Said another way, all of these addresses from 0 to 255 are all on the same IP network. And as a reminder, our subscriber giveaway winners, one for the Packet Guide to Core Network Protocols, Sideshow 9320, and the Packet Guide to Routing and Switching, Idly in there. I haven't heard from you guys yet. I'm sitting here with 2 brand new copies. So send an email to thechickenprotocol@gmail.com or send one right to me, Bruce Hartpence at rit.edu, and I will get those out to you ASAP. So again, subscribe to us here on YouTube, follow us on Facebook, and like us on Twitter. Feel free to add some comments, and of course, may your packets always reach their destinations.